Hello there and welcome to another part of module 3. In this we'll be discussing different addressing modes and how they are used to understand the address of the operand in the memory or in the CPU. The addressing modes are methods that are used to define the operands or the location of the operand in the given instruction. So we can find the operands in the memory or we can find them in different registers. Hence the addressing modes are used to tackle different scenarios and different cases of finding the operands in the memory or the registers. It allows the programmer to be able to use pointers to memory, counters for loop control, indexing of data, and program relocation. These are some of the features that it provides, and it also reduces the size of the address field. So the number of bits in the addressing field of the instruction, so the address part of the instruction, is reduced in size, because sometimes we are pointing towards a sub address or a register which is storing the address. Hence the number of bits gets reduced, so it helps us saving space. The first type is the implied mode. In this mode, the operands are specified implicitly in the instruction, so there is no such address. The operand itself is there in place of the address, so we don't have to go to any specified point. The operand is implied into the instruction itself. Thus, all register reference instructions that use an accumulator are implied mode. So whenever an accumulator is used, it is an implied mode. Zero address instructions in a stack are also implied mode, because it is implied in a stack that the top will always be the operand. You cannot take elements from the middle or the end of a stack, hence it is also an implied mode. So here we can find the operand in the address field. The register mode is a mode where the operands are found in the registers, and these registers reside in the CPU. Particular registers are selected, or a single register is selected from a register field in the instruction. So the instruction will point towards a specific register where the operand will be stored in the CPU itself. So for example, we have MOV R1 R2. So we have selected R1 and R2, and thus in register mode we select registers from the CPU. The register indirect mode. In this mode, the instruction specifies a register in the CPU, and then that register gives the address of the operand in the memory. So this is like the indirect mode, since it's mentioned, but it uses a register. So the CPU has a register that is pointing to an address in the memory where we can find the operand. The advantage of this mode is that the address field of the instruction uses fewer bits to select the register than it would have to specify a memory address, since a memory address will be 12 bits, but to select a register it can be only 6 bits or so, depending on the organization of the computer. So this allows for a smaller number of bits. The auto increment and auto decrement mode. This is similar to the register indirect mode. The only difference is that the register is incremented or decremented either after having accessed the memory or before having accessed the value of the register. So if we have auto increment, then we'll be incrementing the value of the register by 1 before or after we access the memory. When the address is stored in the register, it is necessary to increment or decrement the register after every access. So whenever we store the value in the register, we then increment it or decrement it after the use. The direct address mode is the mode where the effective address is equal to the address part. So in the instruction, we are directly given the effective address, and the effective address is the address at which the operand is stored. So no matter how many addresses we have to go through, the effective will always be the one where the operand is stored. So direct addressing has the effective address in the instruction. Okay, so the address part has the effective address. The operand resides in memory and its address is directly given by the address field. So it does not point to any other address, it directly points to the address of the operand in memory. The indirect address mode is a mode that has the address field of the instruction, which will be giving you another address. So the address field in the instruction will point to a different address, and at that address you will find the effective address. So this will be a two-step. You'll go from one address to another, and at the second address you will find the address of the operand in memory, and then once you go to that address you will find the operand in the memory. Control fetches the instruction from memory and uses its address part to access memory again and finally read the effective address. So we read the memory twice in this case. First for the address that we are pointing to, the indirect address, and then for the effective address, the relative address. In this mode, the content of the program counter is added to the address of the instruction, and this gives us the effective address. So remember, whenever they ask for relative address, take the address and add the program counter value to it. It results in shorter address fields in the instruction format, since the relative address can be specified with smaller number of bits compared to the actual memory address. Indexed addressing mode. In this mode, the content of the indexed register, there will be a register specified which will be called an index register. It will have a value, and that value is added to the address part of the instruction, and then once you add the value, that will give you the effective address. So the address field of the instruction defines the beginning address of a data array in the memory. So indexed addressing is used for pointing towards a data array in the memory. Each operand in the array is stored in a memory relative to the beginning address. So any operand that is stored in this array, it is relative to the beginning address, and the beginning address is the part of the instruction, and then the distance between the beginning address and the operand, the address of the operand, is the index value. So since we are adding index to the beginning address, that means whatever operand we are trying to visit is at a distance of that index from the beginning. Okay, so in the array there will be an array where we'll have 0th element 1 2 3 4. If our index value is 4, that means our operand is stored at the 4th position relative to the beginning, because the beginning address in which we are adding the index is basically the address of the first element in the array. Thus we have to add the index value to get to the operand that we require. Base register addressing mode. In this mode, the content of the base register is added. Again, the base register will be specified. We will be getting what value the base register has, and that is added to the address of the instruction, and then this gives us the effective address. This is similar to indexed addressing mode. The only difference is that now the register is called a base register instead of an index register. The base register is assumed to hold a base address, and the address field of the instruction gives us the displacement relative to this base address. Again, this is also similar to the indexed addressing. The only difference is now we are using a different register. Now here is an example of how we can refer to the different addressing modes. So if we look at this memory, we can see that our address equals to 500. We have load to AC, and then the mode will be given. These are the different addresses. Okay, over here we have the program counter PC at 200. We have R1 as 400. We have XR, which is the index register, at 100, and then we have the accumulator. We have different values stored at different addresses. So when we have direct addresses, when we have direct addressing mode, the effective address will be 500. The address is given here, it is 500. So when we go to 500, we will find the operand, the content that will be stored in the accumulator, that is 800. This is direct addressing because we have the effective address of the operand. Now when we have immediate operand, it gives us 201. So this is storing the address of the instruction address. Okay, so we have 201 and the value is 500. It stores the operand itself. See, so the address equals to 500. We had the address, and when we have 201, when we're pointing to 201, it gives us 500, which will be the operand used. Then we have indirect address. In indirect addressing, we are pointing to 800. Okay, so when we go to 800, that is the indirect addressing. When we go to the address 800, we will find that there is another address 300 over there, and then when we go to 300, somewhere in the memory, that is where we will find the operand. and then we have relative address, which is 702, and we get the value of 702 by adding the value of program counter. So our program counter is going to be 202. Okay, and we'll add it to the address of 500. 202 is our program counter. Why not 201? That is because the program counter always points to the next instruction. So in this cycle the program counter will be 202, and it is not going to be 201 because 201 is the instruction being executed. Hence we add the value 202 to 500, giving us the address 702, which is pointing to. In the indexed addressing, the value of the index register is added to the address 500. So 500 plus 100 gives us 600. Thus we point to 600, where we'll have the content 900. Okay, that will point towards some data, and then you will go there. On the other hand, we have the register. The value of the register is stored 400. Okay, we don't have any effective address yet. We have the register value stored. As we discussed, we'll have the register selected, and it is 400. Hence we have the register value 400. So when we use register in direct mode, thus we will be pointing towards 400. We'll point towards the register 400, and its data will be 700. Finally, we have auto increment and auto decrement. So auto increment, if we consider the register 400, okay, so the effective address is 400, and after accessing that point we increment the value, so it becomes 401. But since we are doing it after accessing, we don't see a change here. In auto decrement, we are decrementing it before we access it because we have already accessed it. Okay, so it becomes 399, and hence we find the data value 450, which is an address for the data which you'll find in the memory. Now considering this question, we can see a two-word memory is stored in memory at an address designated by symbol W. So it is stored in memory at the address W. Okay, so W is the address in the memory for the instruction. The address field of the instruction, which is stored at W plus 1, the address field of the instruction is stored at W plus 1 and is shown by the symbol Y. The operand that we'll be using for the execution of the instruction, it will be stored at an address shown as Z. So operand is at an address Z. An index register contains value X, and now we are going to state how Z is calculated in these four different modes. So looking at the format, we have the opcode mode, which is stored at W. At W plus 1 we have Y. The next instruction is denoted by W plus 2. XR, which is our index, is denoted by X, and Z is the address for the operand. So when we have direct access, we'll be using Z equals to Y, which is the effective address of the operand. Okay, and then for the indirect access, the Z will point to the memory location of Y, and then we'll find an effective address over there, that is Z, and then it will point to the operation. For relative, we are going to add the program counter, hence it becomes Y plus W plus 2. Finally, for the index, we are going to add the index register to it. So Y plus X gives us the indexed value. You can solve different questions in this way, where these are the rules that you have to follow. For each addressing type, direct will point directly to the effective address. The indirect will point to a memory location, which will then have the effective address, and relative will be the sum of the program counter with the address. Finally, indexed is the sum with the index value that is given. Thank you, and see you in the next lecture.